a very basic problem I'm starting. This you have to use in coming numericals. Okay, the bullet, what happened? It gets stuck to it. So let me show the bullet is here. No, what actually happens there? I'll show bullet like this. Here there'll be normal contact, must act. Let me take that normal contact here. And the same normal contact will act on the block A. So let me give name block A, B, and this bullet as C. This normal contact acting on block A, what it does? It will make the block A to move towards right. Then string weapon will be jerked, or even weapon string, if you want, you can show it loose. This A will start moving, then it will be jerked. What do you mean by jerk? Suddenly what happened? The string what happened from will become taut. So sudden increase in tension will set up an impulse. So what is the basic idea? When a force will set up an impulse, I'm giving some graphical thing. So please do follow here. So there's a rule what you are supposed to analyze. So when a force suddenly increases, means here like this. There are changes are there in the force acting on an object, not related to this. It's a generalized one. You can see this interval of time, delta t, or say delta t1. Next again this interval of time, delta t2. Again we have I'm taking the things. So, and finally delta t3. I'll shade it. You can see this. These are the intervals of time for which we should make observation. Look at now this one, delta 2, delta t4. Now force suddenly increase. No, delta t1 is of order micro, milliseconds, or nanoseconds. The force suddenly from zero become non-zero. An impulse is set up here. Next again, but sir, here force constant. We should not take that as impulse. Of course, the body will be, there'll be change in momentum. The force will act, the body will accelerate. Due to acceleration, the momentum of the body will change. Impulse momentum equation you can apply, but when you're discussing problems related to the impulse, no, you should not say there is no impulse. You should not say that impulse is there here. Here, no impulse. An impulse is set up. Suddenly, force from zero becomes non-zero. Impulse is set up. Then again, here, it is having some value, say like some 20 Newton, or say like some 100 Newton, and it has become 200 Newton. Impulse is set up again. Force from zero become non-zero suddenly. Suddenly means, sir, what is the time? 1 hour, half an hour, 1 minute, 1 second, millisecond, microsecond, nanosecond. Usually take micro and nanoseconds. That change the interval of time as an impulse is set up. Suddenly from force zero, it becomes non-zero, impulse is set up. Again, it is having some value. From lower value, again becomes higher value. Impulse is set up. Again, no impulse. Now the force decreases magnitude. From higher value becomes lower value. What? In a small interval of time. You should not say impulse. And again, you look at here, the force is having some value and suddenly becomes zero. No impulse. So when impulse is set up, when force from zero becomes non-zero suddenly, or from lower value becomes higher value suddenly, impulse is set up. From higher value becomes lower value, or from certain value becomes zero, no impulse is set up. So when an impulse is set up by this force, an impulse set up by in times delta T1 and delta T2 only. There's the one basic way of defining the impulse. Means, sir, you only said force into time. Here also that delta 3, T3 and delta T4 also very small. Then why you are not taking? See, like we wanted the what all these changes that are occurring for the force, no? What impact it will have on the system. For that purpose, they are defining it here. For that purpose, they're defining it. So then impulse will happen when force from 0 suddenly become non-zero, or from lower value becomes higher value, impulse setup. From higher value becomes lower value, no impulse. From certain value becomes 0, also no impulse. This is the one basic standard definition for an impulse. Got this? So as in examples, I can show that the like a delta T3 and delta T4. Though when the force changes, there won't be any impact on the system, or there won't be any impulsive setup in this system. Okay, let's come for this. So for what time the bullet will collide with the block? For a few microseconds. Like here you see ball. For what time the ball will collide with the ground? For what time? 4 microseconds. No, I think it's a very natural. You throw ball against a ground or a wall. So ball will be in contact with the ground or a wall for 1 hour or 2 hours, or it's like a 1 minute, 1 second, or few microseconds will be in contact. No, so therefore the collision that occurs, no, usually will occur. The contact time will be few microseconds or nanoseconds. So during that time, the normal
Sir, we can't hear you.
now can you hear me?
Yes, sir.
Okay, I think I started from here. The bullet, what happened, will come and collide. The bullet will be in contact with the block A, like a for maximum for most of the time. But when you should take impulse, the as long as the velocity of the bullet is varying, the normal contact that acts into delta T is what? Impulse. See, the bullet will come to rest inside the block. Previous class I discussed, see, very important. I'm just relating all the numericals here. The bullet will not immediately come to rest. What happened to bullet? It will travel inside the block, no, and will come to rest. And what is the time it will take? Some time, microseconds. During that time, what normal contact force acts, that is impulse. After the bullet comes to rest inside the block, there'll be normal contact between them. That will not come into impulse. That is something like this. When bullet moving inside the block is what the force experienced by bullet or force experienced by the block will be of this kind. Once the bullet comes to rest inside the block, no, there'll be a force between the bullet and that one. They'll exert force on each other. That is what. Then there's no impulse. So is it okay? No, this n delta t. Now this n delta t, what it do? It will make the block 2m also to move. So the string will be jerked. So any impulse is set up in the string, yes, an impulse will come. Sudden increase in sudden jerk. If the string is suddenly jerked, or sudden increase in tension, the string will set up an impulse. I'll call this is JT. Overall sequence, what we have to show that. So because of these impulses, I'm giving in detail description so that the same concept everywhere revolves. Now what all we can do it? The bullet is here. The bullet is inside this one. So that then impulse is acting on it, and because of impulse, this will Jn This will be JT. This will be JT. So this will acquire a speed, say V. This will also acquire a speed. Why? They must have same speed. They're connected by a string. No? The displacement of block A should be equal to displacement of block B for the string to be taut. So overall, this is a sequence. So let's write the equations one by one. So I'll call this as Jn. Now let me look at only for bullet. Let me write the equation. Looking at only bullet. What was the initial speed of the bullet? I'll push it to this, the next page. Let's write, seeing all three diagrams. What was the initial momentum of bullet? mu minus jn. Look at the jn, how it will act opposite to motion of the velocity of the bullet. Jn. This also. Take like this. And finally, what when the bullet will move with the velocity of the block A? So this should be equal to how much? mv. We don't know v, so we can't predict the jn. Okay, let's look at only the overall. Can I apply conservation of linear momentum? Yes, you can apply it. So let me look at the block A. Only on the block A, let me write equation. So what is mu? Only on the block A. So look at the block A. What are the forces? What are the impulses that are acting? Jn towards right, Jt towards left. And what was the initially state of the block A? It was at rest initially. So 0 plus Jn minus Jt equal to 2mb. Then let's look at the block B. Initially it was at rest, no? Then 0 plus Jt equal to mb. Let me take help of this one. So what is this for block B? This is for block A. This is for bullet. No comfort. So what is JT equal to MB? Substitute here. Put 3 into Jn minus MB equal to 2MB. So what is Jn equal to 3MB? Put that 4 in 1. Mu minus 3MB, or sorry, this is Jn is 3MB, no? Equal to MB. So what is V finally equal to? U by 4. Now I know V. So can I calculate what is impulse due to normal contact? Jn equal to 3m U by 4. Then what is impulse due to tension? Jt is equal to mv, no? So this will be m U by 4. This is what overall sequence will happen here. We are discussing problem just after impulse is set up. Means like a Jn first, which impulse will be set up? Normal impulse, impulse due to normal contact, or impulse due to tension? First normal contact, because the bullet should come and collide, no? And what is the Jn? For how long the Jn will act? As long as bullet moving inside the block A, the Jn will be acting. When bullet comes to rest, then the normal contact acting between bullet and block should not be taken as impulse. This is, I'm making things very clear.